Hi everybody, quick little analysis of the simulation you did yesterday. You've got a person here that can push on a box in either direction. We can measure the speed, acceleration, and we can change the friction and all sorts of things. We can even stack a little girl, make her really strong, holding up 100 kilograms of water, whatever. First thing to notice, if you push a little bit, right now, the person is applying a force of 50 newtons to the right. Friction is opposing with 50 newtons. And notice the box doesn't move anywhere. Okay? Person pushes a little bit harder. Friction's a little bit bigger. You still haven't overcome friction. Friction is big enough to keep this thing still. It's not until the applied force is greater that the person in the box start to move. And not only do they move, but they accelerate. There's an acceleration of 0.76, so it's getting faster and faster and faster. The sum of the forces is this green arrow here. It's just the difference between the applied force and the friction force. There's a difference of 144 newtons. If the person were to all of a sudden stop pushing, now the sum of the forces, there's only one force, and it's friction, and it's causing the box to slow down. It has negative acceleration. It's slowing the box down, slowing, and stops, and now there's no left to right forces. If we make the mass of our object here that we're pushing small, maybe just the girl, and we push to the right with a really, really big force, we can get her to accelerate very quickly. Right now there's just friction pushing her to the left, so she's slowing down gradually. If we apply another force, let's try that again. We're going up at a very high speed here. And then all of a sudden we start pushing with friction. She slows down really quickly. Notice that speed's dropping. And then if we continue pushing, now she's going to speed up in the opposite direction. Okay, friction always opposes the direction something is trying to move. So if you're pushing to the left, friction's to the right. If you're pushing to the right, friction is to the left. Last little thing to note. If we take our 40 kilogram girl and we push with, let's say, 200 newtons of force, she has an acceleration of just over 3. Okay, remember that number, just over 3 for an acceleration when we're pushing with 200 newtons of force. Let her come to a stop. I'll slow down a little bit here. If we were to push on this girl with more than 200 newtons of force, her acceleration would be more. If we pushed on her with less than 200 newtons of force, her acceleration would be less. Now, what if we push on a heavier person, twice the mass, with 200 newtons of force? Is the acceleration still going to be just over 3? Let's find out. 200 newtons, not even enough to get him to move. Okay? In order to get him to have an acceleration close to 3.13, we had to push with 400 newtons of force, which was double what we needed to push on the girl. He has double the mass, so you need double the force to get the same acceleration. Force, mass, and acceleration are all related in a way that we're going to learn in a little bit of time.